Hello, Honors Algebra. Mr. Lawrence here with your flip lesson for Monday, January 23rd. All right, today in class, all the 8th graders saw it. My 7th grade students missed it, but I think you'll figure it out. Remember, we talked about multiplying monomials. Like if you, oh no, I'm not in the right mode. If you have 2x to the 5th y times negative 3x to the 4th y to the 5th. To do a simple problem like that, first thing I do is multiply my coefficients. Ooh, what an ugly shade of green. 2 times negative 3, you guessed it, is negative 6. Now I multiply my x's. I have x to the 5th, which remember means x times x times x times x times x. And x to the 4th, x times x times x times x. So what I really have is x times 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 x, which is a mouthful. Why not just say x to the 9th? The shortcut is to go 5 plus 4 equals 9. That only works when the bases are the same. You can only add exponents when bases are the same. In other words, 2 to the 3rd times 2 to the 5th does equal 2 to the 8th. Oh, not 28, Mr. Lawrence. Andrew's going to yell at you. It's 2 to the 8th. Okay, but 2 to the 3rd times 3 to the 2nd does not equal 6 to the 5th. It does not equal that. 2 to the 3rd would be 8. 3 to the 2nd would be 9. That's 72. 6 to the 5th is way bigger than 72. Way bigger. Okay, so let's get back here, and we did our x's. Let's do our y's. I have a y there, and I have 5 y's there. Now, a lot of you want to say the answer to that is y to the 5th. It is not, because I have a y, and then I have 5 more y's being multiplied. Now, if you need a little whoopee in here, stick a little exponent, a little 1 on that y, and you'll see the answer is y to the 6th, because there are 6 y's being multiplied. Now, the bottom of the homework, I do have to point out on problem number 8, there's a small typo. The second quantity says something like this. Right? This 2, this big 2, should be an exponent, so that should be an x squared in there, so make sure you fix that. Okay, now, for division, let's say I have 20 x to the 6th, y to the 5th, z, and I'm going to divide that by, oh, let's say 10 x to the 5th, y, z. All right. Well, I'd like to think about division as fractions. As you know, 20 over 10, well, that's 2. The coefficient is going to be 2. Then I think about x to the 6th over x to the 5th. Well, x to the 6th means x times x times x times x times x times x times x. And x to the 5th means this. Right? And I know that x divided by x cancels out. 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 X divided by x cancels out, leaving me a plain old x, or an x to the 1st. So my solution, my answer, it's not actually a solution, excuse me. My answer, final answer, is going to have a 2 for a coefficient and an x to the 1st power. Now, some of you are going, hey, Mr. Lawrence, all I had to do was take 6 minus 5, and I would get 1, and I know I have x to the 1st, and you'd be correct. So let's do it the shortcut way with the y's. I've got a y here, y to the 5th, and I have a y to the 1st over here. 5 minus 1 is 4, so that's y to the 4th. All right, now I have z divided by z. Now some of you want to say, well, I have 1 and 1, so I get z to the 0. But stop and think a minute. Z divided by z equals 1. Not 1z. Z divided by z equals 1. Just plain old 1. So they cancel out. So z to the 0 power must be the same as 1. All right, there you go. That's division. Now, for Tuesday's lesson, we're going to see problems that look like this. 3x to the 2nd, y, z to the 4th. And that is going to be raised to the 3rd power. Now, some of you are going to get it totally wrong because you're not going to stop and think. All right, let me see here. That's all together, isn't it? Pardon me 1 second. So stop and think. This exponent of 3 outside here, doesn't it mean there are 3 of the things inside the quantity? That there's this, this, and this. And they're all being multiplied together, right? And if you like, I can stick some parentheses around here. Let's see here. Just like this, I should be able to put some parentheses. So I'll have this quantity here, this quantity here, and this quantity here, right? And so now, if I multiply 3 times 3 times 3, I'll get 27. Now I have x squared times x squared times x squared. That's x to the 6th. Hey, look at this. 2 times 3 makes 6, doesn't it? Oh, so when a power is raised to a power, 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 power to the people, when a power is raised to the power, we multiply. When the power is raised to the power, we multiply. So let's see here. We've got y times y times y. That's y cubed, isn't it? Well, if I put a 1 here, 1 times 3, that is indeed 3. All right, now z to the 4th, z to the 4th, and z to the 4th. Well, z to the 4 times 3 would be z to the 12th power. See how simple that is? All right, very simple stuff. Let's try another one here. You can go ahead and pause the video after you see this one. Let's say I have negative 2 x y to the 5th, z to the 6th, and I'm going to raise that to the 5th power. Go ahead and pause it and see if you come up with my answer. My answer is going to be negative 32 x, 1 times 5 is 5, y to the power of 5 times 5 is 25, and z to the power of 30. And there we go. It's just that simple. In fact, this is probably going to be the shortest video we've ever had for a whole class because that's the whole lesson. So remember that when I'm multiplying like bases, multiplying. Oh, Mr. Lawrence, what are you doing? Like bases. You add the exponents. For example, x to the 6th times x to the 7th equals x to the 13th. 6 plus 7 is 13. All right, when you divide like bases, divide like bases, that means you subtract the exponents. So if I add x to the 12th divided by x to the 10th, that would be x to the 2nd. 12 minus 10 equals 2. But when a power is raised to a power like x to the 7th raised to the 5th, that's going to equal x to the 35th. Why? Not y, x. Because it's going to mean x to the 7th times 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 x to the 7th. 7 there, 7 more, 7 more, 7 more, 7 more. I must have 35 altogether. Okay, Mr. Lawrence signing off. We will see you tomorrow. Good night, everybody.